data from the Centers for Disease Control and Prevention has shown that approximately 97% of Americans have detectable blood levels of PFAS. Recently, a scientific review of 40 studies and over 30,000 samples found that PFAS chemicals were in every umbilical cord blood sample tested. People can be exposed to PFAS through 3 different exposure routes. Ingestion of materials or dust which might contain PFAS through the mouth, which is especially a concern for children who have a lot of hand-to-mouth activity. Inhalation, or breathing air that contains PFAS. And dermal transfer, which means they can be absorbed through the skin. While much of the recent attention on PFAS has been about its presence in our drinking water, exposure to PFAS occurs in other ways as well. For example, series research on flame retardants found that children were actually getting their most significant exposure through ingestion, through hand-to-mouth activity. This may also be the case for PFAS, since, like flame retardants, PFAS chemicals are SVOCs. A significant exposure risk is contaminated dust in our environments. PFAS chemicals can migrate out of their original source and settle on dust particles and end up in the dust in our buildings. That building dust can collect on any sort of surface, such as flooring, shelving, and furniture, and carpets or other porous materials. Once the PFAS chemicals get into dust, getting that dust out of buildings is difficult, so dust exposure often becomes a long-term hazard. So, to effectively reduce exposure to these chemicals, these environmental surface routes need to be considered, in addition to airborne exposure or drinking contaminated water. To learn more about PFAS and stay up to date on series PFAS research, visit chemicalinsights.org/PFAS.